Hi everyone, 4.6, we're working with, it's called Arithmetic Sequences is what it's called. We're going to be working a lot and looking at patterns in this section. This is the last section of chapter 4. So here are definitions. You are going to be looking at a sequence, which is a list of numbers that form a pattern. You're going to be recognizing terms, which each number in a sequence is a term. So when you see number values, that is a term. An arithmetic sequence is a list of numbers whose terms all differ by the same non-zero number. So there is a formula working with the arithmetic sequence. Oops. And the formula for that is a of n equals a of n minus 1 plus d. And we're going to be working with this formula. I would recommend you really become familiar with this formula for arithmetic sequences. With arithmetic sequences, here's an example. You have -2, 1, 4, 7, and 10. And we have to think of a pattern. What kind of pattern is getting us from -2 to 1? What is getting us from 1 to 4, 4 to 7, and 7 to 10? Well, if you add 3 to each, for instance, if I take -2 and I add 3 to that, I get 1. If I take 1 and add 3, I get 4. If I take 4 and add 3, I get 7. So to get to the next value, notice my pattern, my arithmetic sequence taking place as we're adding 3. So would you be able to find the next number here? If I have 10, can I find the next value? And the answer would be yes, because you would add 3 to 10 to get 13. So there is a pattern, a sequence taking place by adding 3. -2, 1, 4, 7, and 10, these are all terms. These are all numbers in a sequence. Let's look at an example of working with values and recognizing if they are an arithmetic sequence. So it says, determine whether each sequence appears to be an arithmetic sequence. If so, find the common difference in the next 3 terms. So I'm going to use that formula that was on the previous slide to help me with this, where you have your a of n equals a of n minus 1 plus d. So what I need to do is let's recognize what my a of n minus 1 is. Well, what that is the terms. So my 9, 13, 17, and 21. And then my a of n is my next number. So let's set this up kind of like an equation to find out what pattern could be happening right here. My a n plus 1, this part right here, that's going to be my 9 plus my d. That's going to be the pattern taking place. We don't know what that pattern is, so we can leave it blank. You can put in a variable like, let's say, n or x to help you with that, equals the next number, which is going to be 13 here. So I have 9 plus x equals 13. If I subtract 9 to each side, 13 minus 9 is going to give me 4, so I have x equals 4. Let's use the same formula, a of n equals a n minus 1 plus d, to find what we could get, see what pattern's taking place between 13 and 17. So now I'll set it up. Watch what I'll do here. So I have 13 plus a value, we don't know, we can call that x, equals my next value, which is 17. If I subtract 13 to each side, 17 minus 13 is going to give me 4, so x equals 4. Notice to get from 9 to 13 we added 4. Oops. To get from 13 to 17, we added 4. So let's think about this. If you take 17 and add 4 to it, do you get 21? You do. So is this an arithmetic sequence taking place here? Yes. And what you're doing is you're adding 4 to get to the next value. So what I will mention in this first example is I will say, yes, this example is an arithmetic sequence. Oops, sorry, I spelled that wrong. And the pattern that's taking place is adding 4. Okay, so it says, if so, find the common difference. The common difference here is going to be adding 4. The next 3 terms. So the next 3 terms is going to be well, 21 plus 4 is going to give me 25. 25 plus 4 gives me 29. 29 plus 4 gives me 33. So those would be the next 3 terms for example number 1. Let's now look at example number 2. Here we're going to determine if 10, 8, 5, and 1 is an arithmetic sequence, meaning when you add or subtract a number, you find a pattern taking place, I guess. And so if we do find a pattern, we have to find that common difference and then the next 3 terms. So let's use this formula here, that a of n equals a of n minus 1 plus d, to determine if there's a pattern. Well, we have here 10 plus a number, we don't know what that would be, would equal the next term, which is 8. If I subtract 10 to each side, 8 minus 10 is going to give me negative 2. So we can call this a variable. So my variable x equals negative 2. Okay. Let's look at the next one. We have 8 plus a value equals 5. If I subtract 8 to each side, 5 minus 8 gives me negative 3. So this one, x equals negative 3. Do I get the same common difference? I do not. I first get negative 2, and the second one I get a negative 3. So is the second example an arithmetic sequence? No, because you're not adding or subtracting by the same number to get to the next value. So you can say, no, this is not an arithmetic sequence because there is not a common value that the terms are added or subtracted from. Okay. The next thing you'll see in 4.6 is what's called finding the nth term of an arithmetic sequence. So when you're finding the nth term of an arithmetic sequence, when n is a large number, you need an equation or rule to help you find the nth term. So there is an equation, and the equation is here, where you're going to take a of n equals a of 1 plus n minus 1 times your d, your common difference. So let's do some examples recognizing and finding the nth term of an arithmetic sequence. The first example, it says find the indicated term of each arithmetic sequence. So here I have 11, 5, negative 1, and negative 7. I first need to find the common value, the common difference that's taking place between each term. So when I look at this, let's look at, I start with 11 plus a value is going to equal 5. To find this value x, I'm going to subtract 11 to each side. 5 minus 11 is going to give me x equals negative 6. If I see if there's, if it's an arithmetic sequence, I can look at 5 plus a value equals negative 1. If I subtract 5 to each side, negative 1 minus 5 is going to give me also x equals negative 6. So what is the common value, common difference between each term here? You are subtracting 6. So since that is my common value between each term, I'm going to use the equation, a of n equals a of 1 plus n minus 1. Your n is that nth value, so this would be my 60th, so that would be my nth term, times your common difference d. So what is my a1 here? That is 11 plus, in parentheses, my n minus 1. What is my n? My n, they're wanting me to find the 60th term, so I would do 60 minus 1 times my common difference. My common difference is negative 6 since we're subtracting 6 between each term here. 60 minus 1 is going to give me 59. So I have 11 plus 59 times negative 6. Solve using PEMDAS, orders of operations, so multiply negative 6 times 59, which gives me negative 354. So I have 11 plus negative 354, which is going to give me an answer of negative 343. So using the formula, in finding my common difference, my common value, I can find the 60th term, which is going to be negative 343, by setting it up in this formula with what's already given to me. The last example, number 4, you're finding the 12th term. They're giving me my A1, they're giving me my D here. So using the formula A of n equals A1 plus n minus 1 times D, my A1 is 4.2 plus my n minus 1 is going to be the term, so 12 minus 1 times my D, which is 1.4. And I'm going to solve my answer, A of n. There's a point here. 12 minus 1 is 11 times 1.4 plus 4.2. Multiply 11 times 1.4 first, which is going to give me 15.4 plus my 4.2. 4.2 plus 15.4 is going to give me 19.6. So what is my 12th term going to be? What value? 19.6. So this is a little involved. We are going to do a worksheet in class tomorrow to review this, and along with some bookwork as well.